When a bird of prey hunts from above, it uses gravity as a weapon. It tucks its wings, minimizes its aerodynamic drag, and slices downward through the atmosphere with absolute precision. At over 240 miles per hour, the peregrine falcon is the fastest animal on Earth. In Japan, this apex predator is called the Hayabusa. Human engineering usually demands a physical compromise. If you build a machine for absolute top speed, you generally sacrifice maneuverability. If you need tight agility, you have to add aerodynamic drag, which bleeds away your speed. Over 70 years, 3 distinct Japanese engineering teams found ways to shatter those mechanical compromises. They built a fighter plane, a racing motorcycle, and a deep space probe that each reached the top of their respective fields. And they gave all 3 of them the exact same name, Hayabusa. While these machines operate in entirely different domains, they are linked by that name. It serves as a recurring benchmark, a title chosen for projects that aim to mirror the Falcon's specialized mastery of speed and precision. In the late 1930s, the Imperial Japanese Army Air Force faced a tactical problem. To secure the skies across the Pacific, they required a fighter aircraft with evasive turning capabilities that enemy pilots could not match. The solution arrived in 1941. The Allies called it the Oscar, but the Japanese Army designated it the Ki-43 Hayabusa. Chief designer Hideo Itokawa knew that excess mass ruined agility. To solve this, he systematically stripped away standard protections, omitting heavy pilot armor and self-sealing fuel tanks. The resulting airframe was fragile, but extraordinarily light. Looking at this wing schematic, we see Itokawa's innovation: butterfly combat flaps. Unlike standard flaps, these slotted components extended outward during dogfights. This altered airflow, reducing the turning radius by 20%, allowing pilots to slip inside the turning circle of heavier Allied fighters. By discarding heavy defenses in favor of pure maneuverability, Itokawa created a lethal aerial duelist. It survived not by absorbing hits, but by moving exactly like a falcon in flight, using evasive maneuvering rather than armor to stay alive. Nearly 60 years later, the engineering challenge shifted from the sky to the street. In 1999, motorcycle manufacturers were locked in fierce competition to break the global production speed record. Suzuki entered this race with a machine designed specifically to win it, the GSX 1300R Hayabusa. Hitting the target velocity of 299 km per hour required immense mechanical output. Suzuki generated this thrust using a massive 1,340 cubic centimeter liquid-cooled engine. But horsepower alone cannot overcome the primary physical barrier of extreme speed. As a motorcycle approaches 300 kilometers per hour, aerodynamic drag becomes a literal wall of air pushing back against the rider. As this wind tunnel diagram illustrates, Suzuki's designers solved this by modeling the bike's long, low stance on the aerodynamic silhouette of a diving falcon. The muscular fairings integrated the rider into the machine, allowing the air to smoothly bypass them without generating speed-killing turbulence. This marriage of wind tunnel aerodynamics and massive engine displacement birthed the ultimate sport category, redefining what a street-legal motorcycle could physically do. In 2003, the Hayabusa name left the atmosphere entirely. JAXA launched a probe with a highly complex objective: travel 300 million kilometers through deep space to intercept a near-Earth asteroid named Itokawa. To survive a 6 billion kilometer round trip lasting 7 years, the probe utilized highly efficient ion engines. These provided a continuous, low-thrust propulsion on very little fuel. Arriving at Itokawa presented a unique gravitational problem. The asteroid's gravity is so incredibly low that if the probe attempted a traditional landing, the kinetic impact would simply bounce the spacecraft back out into the void. JAXA's engineers bypassed the lack of gravity by programming an autonomous touch-and-go maneuver. This schematic reveals the mechanism. The spacecraft hovers, extends a collection horn, and fires a bullet into the asteroid, capturing the kicked-up dust. This split-second swoop and snatch operation, executed by onboard computers, is the exact mechanical translation of a predatory bird striking its prey. By executing this precise strike, the probe bypassed the traditional constraints of landing in microgravity. It demonstrated that successful asteroid exploration depended on a specific high-speed interception tactic rather than just brute force propulsion. The original Ki-43 went on to become the most produced fighter in the Japanese Army, and its creator, Hideo Itokawa, eventually applied his understanding of physics to the stars, becoming widely recognized today as the father of Japanese rocketry. Decades later, the Suzuki motorcycle achieved its own cultural legacy. Its physics-defying performance spawned a massive following, with thousands of riders gathering annually in Tottori Prefecture to celebrate the machine at the Hayabusa Station Festival. And in June 2010, the JAXA spacecraft completed its historic mission. After overcoming multiple engine failures, it successfully returned the Golden Re-entry capsule, delivering the first-ever asteroid samples to the Australian desert. Across a span of 70 years, these three disparate machines confronted the absolute limits of weight, drag, and gravity. The name Hayabusa has appeared 3 times over 70 years, each time marking a breakthrough in what a machine can achieve. Whether in the air, on the road, or in deep space, it remains the ultimate designation for Japanese engineering that pushes past the point of compromise.